Hi folks, and welcome to part 2 of this series where we're tackling a library that can insert hidden messages into PNG files. Previously, we've covered chunk types in chapter 1. Now we're going to handle chapter 2. But first, let's have a bit of an introduction. Of course, if you haven't watched part 1 already, I recommend that you do that first. I'll add links in the video and in the description. Okay, first let's have a short discussion about what we'll be doing. I created a sketch beforehand to show you. Alright, so this should kind of represent the PNG file structure. So it will start with a header made of 8 bytes, which is just a specific series of numbers that signifies that the file is a PNG. And after that, we have a series of chunks. And here we have a chunk in detail. Each chunk has this structure. The first 4 bytes represent the length, so these are interpreted as an U32 number. After that, we have the chunk type, also represented by 4 bytes, and this is what we implemented in the last chapter. After that, we have the data, which has variable length from 0 to whatever, and the length, of course, is defined here. It's marked here. And after that, we have the cyclic redundancy check number, which is also 4 bytes. In this video, we're going to be implementing this as a Rust type in our library. All right, let's go back to the docs. Okay, we're at the proper chapter. We're going to have to use the CRC crate for the cyclic redundancy check. We could also code this on our own, but it's a bit complicated. So we'll just use the crate. Let's go to the assignment. Okay, we have to implement the chunk using the spec. Okay. Let's see the requirements. Copy the unit tests. I'll just scroll down and copy these so it doesn't wrap the functions up. Let's go to our IDE, which I already have opened. Let's see, chunk. I'm going to paste the tests. Oh, and while we're here, cargo add. Gonna add the CRC crate. So we have it already. Okay, back to the assignment. Okay, we have to write a chunk type. We have to implement try from slice of U8 for it and display. Let's try doing this. Let's define a placeholder at least. Pub struct just chunk. We'll leave it at this for now. Implement try from for chunk. Okay, let's create the blanket implementation. And we also had to implement display. Implement display for chunk. I think this is not imported. Again, blanket implementation. Okay, let's go back to the assignment. Okay, these are the required methods to have the tests pass. Let's just copy these. Let's define an impl block for the chunk. And I'll just paste the methods here. Okay, first order of business. Let's import the chunk type, which we already have in our crate. Okay. Let's just return a new chunk here to get this to pass. Length, let's just return a random number. This is a bit more complicated for now. I'll just leave it like this. Same goes here. Another random number. Okay. And here, let's just call the vec macro. Why are we getting an error? Oh, in main, we have some type aliases. So we have a dynamic trait object for the error, which is type to error. And we also have a result which has this error already mapped to it, and is just generic over the type that we're returning. And this has the result alias. And I think here it's importing another result, and that's why it's getting the error. Or maybe I can just use crate at result. And I think here we can just, yep, remove this. This works. Okay. This looks good for now. Okay. Let's start by defining the chunk type. And as we said, we need to have a length, which will be a U32. A chunk type, which is the chunk type. There's also the data, which would have variable length, which we're going to store into a vec of bytes. And the CRC, which is just going to be another U32. That should be fine. Okay, let's try to implement try from. First, let's just cover the error, and it should be the one in the crate. Oh, and I think we might need to do this here as well. Forgot about this. Okay, I think it's the one in the crate. That's good. Let's go back. This might be where the most of the work is. Let's see. So we're getting a sequence of bytes, and we need to collect all of these and then return them in the chunk structure. So let's define an iterator. Let's say, yeah, I'll just call it iter for now, or maybe, yeah, iter is fine. And this is value.iter. And we're going to have it copied, because otherwise we're going to get references. Okay. Now we need to collect from this iterator. We need the first 4 bytes, which will be the length. So let's do that. Say first 4, which will be a vec of U8s of length 4 equals iter. We're going to use the byref adapter. This essentially will modify the iterator instead of just consuming it when we call operators such as take. because we want to continuously take and modify the iterator to get all these parts in sequence. Okay. We have byref, and now we can take 4 bytes and we can collect these initially into a vector, say a vec of u8, and from the vector we're going to convert into the slice, so as slice, but now the slice doesn't have a fixed length, so we're going to use try into, and I think this is a result. Maybe we can change the error. That looks good. We have an error here for the iterator. Oh, since, yeah, as I've said before, with byref, we're modifying the iterator, so it needs to be mutable. Let's just change the binding. Okay, that fixed it. Okay, now we need to get an U32 number from the first 4 bytes. And let's say let length is equals U32 from, oh, this is good, from big endian bytes. And we need to give it the bytes. Okay, let's just say first 4, that should be good. So we have the length. Now we're going to have to get the chunk type. Let's grab the bytes again. Say let chunk type bytes. We're going to define the type again. It's also 4 bytes in an array. Okay, we're going to take again from the iterator, modifying it. Take 4 bytes. Of course, collect into the vec of u8, turn into a slice, use try into to get the fixed size property. Okay, and now we have to get the actual chunk type from the bytes, and we should have let chunk type equals chunk type. Okay, try from. We already defined this in the previous chapter from the chunk type bytes. Yep, that should be good. Okay, next we have the chunk type. Now we need to get the data. The problem is that the data has a variable length. We have the length here. Yeah, we can just take that. Let's say let data bytes. Oh, I think we can just say data maybe. The data, this will be a vec of u8 as we've defined it here. Okay. Again, we're going to take from the iterator. Okay. Take length. I think it's complaining. Okay. As u size. Okay. Dot collect. Okay. Now we have the data bytes as well. And we should have 4 more bytes for the CRC. let's say let CRC bytes the same again, byref take 4 dot collect vec of u8 as slice try into, and we have to define the type. Okay, I'm gonna change the error again. Also, a note here, you don't have to do as slice, you could also do try into, but this just helps with the error. By doing it this way, it returns an error that can easily be changed without writing converters for it. So this is why I'm doing it. All right, now let's do the same thing to get the U32 from these bytes. U32, oh no, U32 from big endian bytes. And here should just have the CRC bytes. And we can just return an OK variant. Okay, with a chunk which has length, chunk type, data, and CRC. Okay, we have a problem. Okay, for the chunk type, yeah, we're getting a result. Let's unwrap that and change the error. Okay, looking good. Okay, let's see for the next ones up. Okay, let's do display now. We're going to invoke the write macro. I'm going to pass in the formatter, the format string, and the variable would be, I think we're just going to return the inner data of the chunk without the metadata as a string. So that would be self.data as slice. Okay. And I think we can just use string from. I think that should be enough for now. Okay, let's do the new method. So we have a chunk. So we're going to have the length, which will be data.len. Okay. As U32. That's good. Chunk type. Yeah, just the chunk type. Oh, yeah, we can use the shorthand already. Data and CRC. Okay, we need to calculate the CRC. Okay. Let's just go back and open up some documentation. This is the CRC crate. So this is how we kind of use it. Okay. Let me just copy this. Go back to the IDE. All right. Let's say use CRC. Yeah, the CRC struct. Now let's define the constant as they did on GitHub, and that would be say const CRC, which is CRC 32. Oh, yeah, I can delete this. We already have the use statement. We have a U32. We don't need this, but we need to use a different algorithm. And yeah, this is the one being used. You're gonna have to do a bit of research on your own to see why it's in the specs, but yeah, I've checked it already. Let's define the algorithm. Doesn't like something. Constant provided and type was expected. I've made a mistake. This should be U32. Okay, this works. Let's check the specifications again. Okay, let's go back. And going to get the PNG spec. Okay, so the CRC needs to be calculated. Okay, the preceding bytes in the chunk. Oh, the chunk type code and data field, but not the length. So it's just these two. Okay, let's go back to the IDE. So when we calculate this, here it's okay because we're getting it from the byte sequence already, though we might need to check it in the future. But here we need to calculate it. Let me define new method. I need to get the bytes from these two together. So let's say function get bytes for CRC. And this will take chunk type, which will be a reference to chunk type, and data, which again will be a reference to the data. We don't need to own these for this. I'll just return a vec of bytes. Let's just define a kind of result container. It should be an empty vector. Okay, and now we're just going to extend this vector with the values in these two. So container.extend. This will add the values in a collection to the vector. Okay, chunk type. We need to get the bytes from it. I think we already have the method, but it's just not public. Let's go to the file. Okay. Oh yeah, not public. Let's make it public. And we can just call bytes on it. Okay. And oh, Yeah, it's not mutable. Let's change the binding. And now let's extend it with the data as well. Container.extend. I think we can just pass in the data. That should be good. Yep. And now let's just return it. Yeah, that should be fine. Okay, and the CRC should be, we have the CRC constant defined. So we have the constant. Okay. CRC.checksum? No? Okay. Let's change this. This was the issue. Now let's try to use the method we defined. Get bytes for CRC. Reference to chunk type. Reference to data. Let's check the issue here. Okay, it's expecting a slice. Let's just try as slice. Close the parenthesis. Looks good. Okay. Let's go fix some of the other methods. Here we can return self.length. Here a reference to self.chunkType. Self.data as slice should be good. Self.crc. Data as string. So we need to return, let's try an OK variant. And use string from UTF-8. And we need to, I think we can just pass the data. Self.data. This can fail, so let's change the error. It's trying to move here. This takes ownership. Can we try with a reference? Oh no, it's already. I think we can just clone this. Yes, that's good. As bytes. Do we need to return all the bytes? I think I'm gonna leave this for now and just check again later. All right. Let's check if this compiles. So cargo check. It doesn't. All right. Okay. Oh, I was trying to do the normal from. Let's update this part where we're implementing the display. And I think I can remove this because we already wrote a method. The data as string method. So it should just be self.data as string. Oh, and I think we can just unwrap this. I won't try to chain the error because I'll have to handle the conversion between the error types. Okay, let's try again. Cargo check. We have another move in the new method. Okay. So we're trying to use these two references to chunk type and data, but they get moved when I assign them to the fields here. I think we can just move this up, this assignment, and that should fix it. Let's try again. Good. It's compiling. Let's try to run the tests and see how much we've covered so far. Oh, that's great. I wasn't expecting it to cover so many use cases at once. All right, we still have to handle one of the tests. Okay, the as bytes. And let me try. Oh no. I was thinking if it's just okay to return the data bytes, but I think it's expecting all the bytes in succession. So let's try to do something similar as we did for the concatenation, for the redundancy check calculation, like here. Okay, let me close the console for now. Let's say that we're going to define an empty vector. Okay, now let's extend the vector. And container dot extend self dot length. Can I? Oh, that's perfect. Yeah, we have a utility method that converts the length to bytes, so we can select this to big endian bytes. All right. Okay, of course we have to make the container mutable. Let me change the binding. Okay, the length, after the length we have the chunk type. Container extend self dot chunk type to bytes. Okay, now we have to extend it with the data. Container dot extend self dot data. I think that should be good. Okay, it's moving again. Can we give it a reference? That works fine. Okay. Container extend self CRC to big endian bytes. I think that should be fine. Okay. Oh, we're not returning anything. Let's return the container and try the tests again. Oh, it's still failing. Okay, let's try to run the tests in the visual mode. I want to locate the one that's failing. Okay. So, it's expecting an error in this case. and we're returning an OK variant. OK, and this is invalid because I think it's the CRC. Let's look above. I think this should be the valid use case. Okay, this is the valid one. And this is the correct CRC number. And this is different. So I think we need to check the cyclic redundancy check number when we create it from new bytes. Okay. And I think that should be from the from trait, as in here, the try from. Okay, so here we're just getting the CRC number from the bytes and we're not checking if it's correct. So we should also calculate the CRC here and double check. All right, let's try that. Okay, let calculated equals, it was CRC dot checksum, and we have to get the bytes again, and it was self dot maybe just chunk. No, the type dot. I think the issue here is that we're trying to access a method on the chunk type and it's not public. Let me try this because we're outside the type here. And let's try chunk. Yes, that was the case. Okay. A reference to chunk type. And a reference to the data. As slice, and that should be good. Okay, now let's check if calculated is not equal. In this case, we should return an error. Yeah, the crate error from invalid CRC. Okay, else think we can just move the OK variant. Let's try to check this. Good. Let's format it. And let's try the tests again. Oh, great. Everything passed. All right. We finished chapter 2 of the book. And in the next part, we'll be working on the PNG type. Thank you for watching, and I'll see you next time. Let me know if you have any ideas for further videos or questions in the comments.